Hello students, today we will learn about modulation, analog modulation and digital modulation. Today, vast amount of information are communicated using radio communication system, both analog radio communication system and digital or data radio communication links. Let us first talk about modulation. It is the technique used for transmission of signal to long distance. It is very common that if we need to send a signal covering a distance, it must have some potential to travel that distance. With the help of some technique, that traveling potential has to be increased without changing the original signal. The fundamental aspects of any radio communication transmission system is modulation. There are many ways in which a radio carrier can be modulated to carry a signal, each having its own advantages and disadvantages. The choice of modulation has a great impact on the radio communication system. Some forms are better suited to one kind of traffic, whereas other forms of modulation will be more applicable in other instances. Choosing the correct form of modulation is a key decision in any radio communication system design. The process of impressing low frequency information to be transmitted onto a high frequency wave called the carrier wave by changing the characteristics of either its amplitude, frequency or phase angle is called modulation. The main function of the carrier wave is to carry the audio or video signal from the transmitter to the receiver. The wave that is resulted to the superimposition of audio signal and carrier wave is called the modulated wave. Modulation is a process in which the baseband signal modifies another high frequency signal called the carrier, in which some characteristics, usually amplitude, frequency or phase of a carrier is varied in accordance with instantaneous value of some other voltage called the modulating voltage. In other words, we can say that modulation is used because some data signals are not always suitable for direct transmission, but the modulated signals may be more suitable. Example, a paper which contains the message and you would like to send it to your friend standing 30 feet from your place. You can't just throw the paper to your friend because paper will not travel that much distance. But if you take a stone and cover the paper with it, then throw it to your friend, it will definitely reach the target. The same way, we need a carrier signal to transmit our message. Sometime, message signal is called as modulating signal. It has three parameters. The first term A is called the magnitude or amplitude. The second is known as the frequency, and the third term is known as the phase. The modulation technique is broadly classified as analog modulation and digital modulation. Analog modulation. In analog modulation, analog signal is used as a carrier signal that modulates the message signal or data signal. There are three basic types of analog modulation: AM or amplitude modulation, FM or frequency modulation, PM or phase modulation. Digital modulation. Digital modulation means an analog signal in which carrier is converted by a digital data bit stream. Digital modulation is somewhat similar to the analog modulation, except baseband signal is of discrete amplitude level. For binary signal, it has only two levels, either high or logic 1 or low or logic 0. The modulation scheme is mainly three types: ASK or amplitude shift key, FSK or frequency shift key, PSK or phase shift key. Types of analog modulation. Amplitude modulation, a type of modulation where the amplitude of the carrier signal is modulated or changed in proportion to the message signal while the frequency and phase are kept constant. Frequency modulation, a type of modulation where the frequency of the carrier signal is modulated or changed in proportion to the message signal while the amplitude and phase are kept constant. Phase modulation, a type of modulation where the phase of carrier signal is varied according to the low frequency of the message signal is known as phase modulation. The method of varying amplitude of high frequency carrier wave in accordance with the information to be transmitted, keeping the frequency and the phase of the carrier wave unchanged is called amplitude modulation. The information is considered as the modulating signal and it is superimposed on the carrier wave by applying both of them to the modulator. Amplitude modulation is first type of modulation used for transmitting message for long distance by the mankind. The AM radio ranges in between 535 to 1705 kHz, but when compared to frequency modulation, the amplitude modulation is weak, but still it is used for transmitting message. Here we will modulate a signal as follows. The audio electrical signal wave is taken as an information bearing signal. It is modulated with the carrier signal and the amplitude modulation wave is produced. Here frequency of the modulated wave is same as that of the carrier wave, only amplitude of the wave varies. The carrier wave has positive and negative half cycle. Both these cycles are varied according to the information to be sent. The carrier that consists of sine waves whose amplitude follows the amplitude variation of the modulating wave. The carrier is kept in an envelope formed by the modulating waves. Advantages of amplitude modulation. In amplitude modulation, we use simple and low cost circuit. We don't need any special equipments and complex circuits that are used in frequency modulation. Because of amplitude modulation wavelength, AM signals can propagate longer distance. Bandwidth limit is also a big advantage in amplitude modulation, which doesn't have any frequency modulation. The amplitude modulation receiver will be wider when compared to the FM receiver, because atmospheric propagation is good for the amplitude modulated signal. Disadvantages of amplitude modulation. More power is required during modulation because amplitude modulated signal frequency should be double than modulating signal or message signal frequency. Bandwidth requirement is very high as it has to send two sidebands along with the carrier. Difficult to tune in the absence of the carrier. Application of amplitude modulation. Used to carry message signal in early telephone lines. Used in Navy and aviation for communication as AM signal can travel longer distance. Widely used in amateur radio. Frequency modulation is a system in which the amplitude of the modulated carrier is kept constant, while its frequency and rate of change are varied by the modulating signal. The big advantage of frequency modulation is its noise reduction ability, because most of noise appears as additional amplitude, and in the FM the amplitude of signal is hold fixed. This type of modulation is commonly used for broadcasting music and speech, magnetic tape recording system, two-way radio system and video transmission system. When noise occurs naturally in radio system, frequency modulation with sufficient bandwidth provides an advantage in cancelling the noise. The amount by which the signal frequency varies is very important. This is known as the deviation and is normally quoted as the number of kilohertz deviation. Example, the signal may have a deviation of plus minus 5 kHz. In this case, the carrier is made to move up and down by 5 kHz. Advantages of frequency modulation. Frequency modulation has more noise resistivity compared to other modulation technique. That's why they are mainly used in broadcasting and radio communication. For transmitting message in frequency modulation, it does not require special equipments like linear amplifier or repeater, and transmission level or higher when compared to other modulation techniques. Transmission rate is good for frequency modulation when compared to other modulation, that is frequency modulation can transmit around 1200 to 2400 bits per second. Frequency modulation has a special effect called capture effect, in which high frequency signal will capture the channel and discard the low frequency or weak signals from the interference. Disadvantages of the frequency modulation. We do not need any special equipments in the transmission section, but in the reception we need more complicated demodulator for demodulating the carrier signal from message or modulating signal. Frequency modulation cannot be used to find out the speed or velocity of a moving object. Static interference are more when compared to phase modulation. Outside interference is one of the biggest disadvantages in the frequency modulation because of nearby walkie-talkies, radio station, construction or pages. To limit the bandwidth in the frequency modulation, we use some filter which will again introduce some distortion in the signal. Transmitter and receiver should be in the same channel and one free channel must be there between the system. Spectrum space is limit for the frequency modulation and careful controlling of the deviation ratio. Application of frequency modulation. Frequency modulation is used in radios, which is very common in our daily life. Frequency modulation is used in audio frequency to synthesize sound. For recording the video signal by VCR system, frequency modulation is used for intermediate frequency. Used in application of magnetic tape storage. Phase modulation (PM) is used in many applications to carry both analog and digital signals. Keeping the amplitude of the signal constant, the phase is varied to carry the required information or signal. Phase modulation is used for transmitting waves. It is an essential part of many digital transmission coding schemes that underlie a wide range of technologies like GSM, Wi-Fi and satellite televisions. Forms of phase modulation. Phase modulation is used for some analog transmission. It is far more widely used as a digital form of modulation, where it switches between different phases. This is known as phase shifting key (PSK), and there are many types of PSK as well. It is even possible to combine phase shift keying and amplitude keying in a form of modulation known as quadrature amplitude modulation (QAM). The list gives some of the form of phase shifting keying that are used. PM phase modulation, PSK phase shift keying, BPSK binary phase shift keying, QPSK quadrature phase shift keying, 8 PSK 8-point phase shift keying, 16 PSK 16-point phase shifting key, QAM quadrature amplitude modulation, 16 QAM 16-point quadrature amplitude modulation, 64 QAM 64 quadrature amplitude modulation, MSK minimum shift keying, GMSK Gaussian filtered minimum shift keying. Advantages and disadvantages of phase modulation. The main advantage of phase modulation is that it has less interference from static, which is why we use this type of modulation in finding out the speed or velocity of a moving object. In frequency modulation, we cannot find out the velocity of a moving object. The main disadvantage is that the phase ambiguity comes if we increase the phase modulation index, and data loss is more, and we need special equipment like frequency multiplier or increasing the phase modulation index. Application of phase modulation. Phase modulation application is not different from frequency modulation. Phase modulation is also used in communication system. It may be used in binary phase shift keying. In digital communication, the modulation process corresponds to switching or keying the amplitude, frequency, or phase of the carrier wave according to the incoming digital data. In digital modulation, an analog carrier signal is modulated by a digital bit stream. Digital modulation methods can be considered as digital to analog conversion, and the corresponding demodulation or detection as analog to digital conversion. The changes in the carrier signals are chosen from a finite number of M alternative symbols, the modulation alphabet. For a better quality and efficient communication, digital modulation technique is employed. The main advantage of the digital modulation over analog modulation includes bandwidth, high noise immunity, and permissible power. In digital modulation, a message signal is converted from analog to digital message and then modulated by using a carrier wave. The carrier wave is switched on and off to create pulses such that the signal is modulated. The type of digital modulation is decided by the variation of the carrier wave parameters like amplitude, phase, and frequency. The most fundamental digital modulation technique are based on keying. ASK, amplitude shift keying, a finite number of amplitudes. FSK, frequency shift keying, a finite number of frequency. PSK, phase shift keying, a finite number of phases. QAM, quadrature amplitude modulation, a finite number of at least 2 phases. In an amplitude shift keying, the amplitude of the carrier wave changes based on the message signal or on the baseband signal, which is in the digital format. It is sensitive to noise and used for low band requirements. In frequency shift keying, the frequency of the carrier wave is varied for each symbol in the digital data. It needs larger bandwidths. Similarly, the phase shift keying changes the phase of the carrier for each symbol and it is less sensitive to noise. We have different types of digital modulation techniques: amplitude shift keying ASK or on-off keying OOK, frequency shift keying FSK, pulse code modulation, phase shift keying, quadrature phase shift keying QPSK, minimum shift keying MSK, Gaussian minimum shift keying GMSK, quadrature amplitude modulation QAM. Apart from the type of modulation itself, the type of signal being used to modulate the carrier also has a posture on the signal. It is often important to know the signal type that needs to be carried by the RF carrier. In this session, we have understood modulation, amplitude modulation, frequency modulation, and phase modulation with important advantages, disadvantages, and their application.